Hi everybody, this is Bob, and I've been working on the QCX Plus 40 meter transceiver CW, and I just received the kit and I showed you an unboxing video, and I wanted to show you some tricks here about magnification working on these. And you may notice I have two pair of glasses on, and these right here are are 2-power reading glasses, and I slip on these, which are 4-power reading glasses, and I believe that gives me then 6 power, and it really makes a difference. And you need magnification like that when working on something like these little tiny parts on these circuit boards. So I wanted to show you something about magnification here that will help, especially if you haven't got any really good magnifiers to wear. Normally on this type of thing I use this type of magnifier. This is an Optivisor 5-power. It also has the loop on it, and I believe the loop is also a 5-power that you can swing down to get more magnification. But I find that the 5-power is just about right, and that the 4-power reading glasses worn over the 2-power reading glasses work really good. So I just wanted to show you that. Maybe you don't have a really good thing like the Optivisor to wear, but you probably do have some reading glasses. You can also get reading glasses that work pretty good at the dollar store. So I just wanted to mention that. And I have gotten quite comfortable wearing 2 pairs of glasses, one over the other. It works pretty good. Now, another thing I wanted to talk to you about, I copied the manual out of the website for the OCX Plus 40 meter CW transceiver. And you turn the first few pages in the manual, and what do you come to? They tell you right here to wind and install transformer T1. And this is quite a complex transformer. It's got 1, 2, 3, 4 windings. They all have to be wound exactly the same direction, and then they have to match up with the holes that you have here. And I ran this manual off. I wanted to mention that too. I ran this manual off on my printer. It's 137 pages, the manual is. I think they go into extreme detail on this, and I think that is probably overkill, but it's okay. Anyways, I ran off the 137 pages of this because I like things in a hard copy. I'm an old school kind of guy. I don't like working on a computer getting all that stuff. I get mixed up on the computer commands and things, and then I get frustrated, so I just don't go into that. I do it by copying the manual if I can, and work from a written hard copy manual. Okay, on these making this coil, I did a couple of things different, and I'll show you what I did here. When I put each winding on, like here's a winding of 5 turns here, I put those 5 turns on, and then I took that little wire of those 5 turns, the 2, and I just wrapped them around each other, just one tiny wrap like that, to hold them in place. So the 5 turn windings, here's 1, 2, 3, I put them on that way. And here's the long one here. This is 38 turns, that's 5, and that's 5. And there's your toroid core. And so what I did that for was that on each one of these windings, I then put a little tiny drop of E6000 glue. Now this E6000 glue I have used for years and years and years. It has no effect on coils. You can put it on even when it's wet. Even when the E6000 is wet on there, it will not affect the inductance or the tuning. It is just a really, really good coil dope type of thing. We used to call it coil dope because it came in a little bottle with a little brush like a paintbrush, and it was a dope type of thing. But this is just the E6000 glue. You can buy it at your big stores, your big box stores in the craft department. You can also find it in many hardware stores. I think they even have it in the Dollar Tree stores. Not Dollar Tree, excuse me, not Dollar Tree, Dollar General stores. I have found it in Dollar General stores. Okay, anyhow, I gave a little twist on each one of those, and I took the little tiny screwdriver here, and I took a little tiny bit of the E6000, and I dabbed it on these points here. I put a little bit here, a little bit here, a little bit here, a little bit here, and a little bit here. That held all of those things nicely in position. Another thing that I did on this is that there we go, getting the wire ready for, there we are, getting the wire ready and tinning it. And I found out, you know, I worked at Heath Company, and the wire that we used at Heath Company was a type of wire that you could, I'm getting this camera all set up yet here, a type of wire that you could simply heat up with a soldering iron, and it would melt off of the wire, the coating off of the wire, so that you could tin it. And I'm getting ahead of myself here now. Anyhow, I wanted to show you how to do that. I have my soldering iron that I've been using here for this, and I just put a glob of solder on there like that on the iron, then touch it to the tip of the wire, which is which has got the copper part there, and you can see there, and what happens is that heats up that tip of that wire, and that wire then accepts the solder, and then you rub it like that down the side, and you can see that the insulation came right off of that wire, the enamel, and that's an easy way to tin that type of wire, and it really works good. So anyhow, I just wanted to show you how to do that, and it worked out really good for me on this. Now here is my circuit board with the toroid that I wound, and it came out just fine. Now I wanted you to notice here, pardon my pauses and things, I'm not a professional at this, I'm just trying to show people how this thing goes and help people to do the job. I'm an old, like I say, an old school kind of guy. So then what I did was these wires on the toroid, I cut those all to 1/2 inch long, and they are held in place then by the E6000. You can see some there, and there. And so then I just flipped that over, that toroid, and spread those out and tinned them like I showed you. Then I had to put them through the holes, and if you look at this circuit board, I can't really show you here now because it's got the toroid on it, but right across here between these two, this is one winding, and underneath on the board there's a white strip. Same thing for all the other windings, and that is shown in the manual as well, right here. Here's one winding, goes here, and you see the little strip there? That's done with white paint on the circuit board. Let me get this better. There we go. That little strip right there. And then there's a little strip right here, and a little strip right here. And then this one here, you see they've drawn a little red line all the way around on there. This is page 18 in the assembly manual. It's the first thing that they have you do is wind this toroid. Why is that? Well, because it's a difficult thing to do, and it's much easier to do when you don't have the other parts on the board. So they show you how to do that, and if you look at this, this is just the way it is on the board. So you put those wires in, and also you can compare with the the picture that they have here. You see how they all go the same way, like that. Starts here, round like that, and that one starts over there, goes round like that. They all start the same way. Another thing that I found was rather distracting was counting the turns. Be sure you count the turns that go through the hole. If it says 5 turns, 1, 2, 3, 4, 5. 5 turns through the hole. And the same thing with this one. This is 38 turns through the hole. And I counted that with this little screwdriver here that I have here, and my extra reading glasses on top of reading glasses, 2 pairs of them. And I just went over the wires like that. And I get a little confused here, and I sneezed once, and so I just put my little screwdriver between that one right there and did my sneeze, and then I continued counting. And I counted it twice to be sure I had 38 exactly. Now, when you get finished with that, you can also go to the bottom side of the board. And I think this transformer is so important, and it's difficult, so that's why I'm making this video just on this part. So I went down here with my little tiny Sharpie pen, permanent marker pen, and it's got the very smallest tip marker pen. And if you notice here, I put a little bar between this one and that one, that one and that one, and that one and that one. This is the 5 turn windings. 1, 2, 3, 5 turn windings. And the 38 turn winding, I draw little row of dots there between this one and this one. And then I was able to take my ohm meter, and I can check between here and here. I should get continuity. I did. Here and here I should get continuity. Here and here I should get continuity. And I use my Simpson 260, which has the beeper on it, like this. I'll just do the one winding, the long one there, from here to here. I don't know if you can hear that beeper, but it is beeping. You can check that before you put the other components in. There's nothing else connected to it there. So these are all separate and nothing connected. So you can check your transformer on here, just like I did, between this one and this one, that one and that one, that one and that one, that one and that one. And this transformer is so important, and it's such a difficult little thing to make, that I thought I'd just go ahead and make a video on that. And let's see. Well, I think I just about got everything here. I am standing up while I'm working. That works out best for me at age 78. If I sit, my muscles give me problems, my stomach gives me problems and all. So if I keep my body straight and I stand up, I don't have those problems. So that's why I'm working this way. I just put this box on the workbench. I got a piece of cardboard up here on top. I got my tools and my soldering iron up here. And I got my other tools right down here that I can get to. I just wanted to show you that. If you're an older guy like me, maybe it will help you to stand up. And I guess that's it for this right now. And what else do I have? I don't have anything else on here right now. It took me quite a while to copy this assembly manual. For 2 reasons. First of all, I did a few pages and my printer stopped working. So then I had to clean the print heads, and I went through the print head cleaning process. It's got a program for that. I have an ET 2550 Epson printer with the ink tanks on it. So anyhow, I ran it on clean. I had to run it on clean 5 times in a row, and it started working again. It's done that before a couple of times. I think you can do a better cleaning job if you take it all apart. If you want to do that, to me it was easier just to run the cleaning program over and over. And yeah, I used some ink. I don't really care that much about that. That's okay. You will find in the manual here when you start assembling your transformer that they have this drawing in here that was done by Ed, WA4MZS. And Ed, you did a beautiful job on that. That was a huge help to me in assembling that transformer and getting it on the board properly. So that's in the assembly manual there, so to help you out on that. And the other problem I had with the assembly manual is that you see the edges, how ragged they are? All I had here was the large size paper. I ran out of 8.5 by 11, but I had a whole ream of 8.5 by 14. So I set a piece of 8.5 by 11 on here and drew a line and cut 3 inches off of this whole stack of 8.5 by 14 paper. Printed out beautifully on the Epson printer, which I really like. And I have done tons of printing with that printer. And you just dump the ink into there. You got to be really careful though with the ink. You know, that stuff, you spill it and it gets all over and it's hard to get off. And you don't ever want to pick up your printer and turn it upside down or tip it, because the ink tanks will just drain the ink all over the place. I have not done that, but I have heard that it has been done by some people. Anyways, I wanted to show you these things. I think I pretty much covered everything that I wanted to cover there. This is a real fun project for me. The solder that I'm using is this is Kester 6040. You want the 6040, which is low temperature melting, and the size of the solder is 0.031. You want smaller solder, so that you're not getting solder all over the place when you're assembling that circuit board. So that's it, and we're going to go ahead and start putting the parts in. One thing I don't like about the circuit board is my preference, but they mark on here, you see here the resistors marked. Here's R31, R32, R33, R34, R35. I worked at Heathkit, and instead of having R31 here, we would have 100 printed there for 100 ohm resistor. Maybe on another one we'd have 1000 printed, or 10K, or 22K. And by marking them that way, then you don't have to go to the to the manual to see what the value is. You don't have to go to see what R131 is. And I think it makes it a lot easier to do that way. But hey, that's just me, because I worked at Heath Company and we did them that way. So what else? I guess that's it, guys. So this is a really nice kit, I think, to put together. I'm impressed with the quality. I'm not crazy about the resistors. The resistors are different than what I'm used to. If you look at these, it's hard to see what values they are because of the colors. I see there's diodes on that strip too. But on these resistors, with the blue paint and the colors on the blue paint, it just, they very difficult for me to glance at it and see what value they are. And after all these years, I have learned my resistor values where I just glance at them and I know what they are. I don't have to look them up. But these things, ugh. And what I'm doing, I've got a very accurate ohm meter, the Fluke 8050A right there. And what I do with the ones that I have difficulty looking at the resistors and determining what the value is, I just put the Fluke 8050A on there, and I know what the value of the resistor is just by using the ohm meter. So that's a suggestion too that I make to you, that you can do that. Use a digital ohm meter and use that to measure your resistors if you have any doubt about what the value is because of the colors. But the way my eyes are, I have difficulty with that and the blue paint on the resistors. That's it, guys. This is video number 2 on this, and I plan on making others as I go along. Probably the next one will be after I get the board all populated. So with that, I'll say 73s and good DX.